This assessment asks us to justify the formation of the products in one of the figures in the book. Now, in that figure, there are 4 different products. We're only going to show one of them here, and then just acknowledge that the other ones are going to form by a similar mechanism. So all of these reactions are in the context of the crossed aldol reaction, and we know that the crossed aldol reaction is going to make 4 different products in similar yields when done a certain way. So we'll show the mechanism of the first. In this case, we're going to start with an enolate, which I will redraw, and it's going to react with this aldehyde to eventually make this aldol product. There will be water present, so when we need a proton source, we'll use that. Now, this particular enolate has formed by being deprotonated by hydroxide, and so that helps us understand why there's water present in the reaction. But the reaction is going to start by this enolate reacting with this aldehyde. And so let me make sure we get all the carbons present. These electrons are going to come down and push out the pi electrons here to attack the aldehyde carbon, pushing the pi electrons onto oxygen. This reaction is reversible, and that's one of the reasons we end up with so many products in the crossed aldol reaction, is because of that reversibility. But the product that we're going to end up making initially is this. Now, anytime we draw a mechanism, we're always going to want to number the carbons to make sure that we haven't correctly drawn the mechanism but incorrectly dropped carbon. So we'll number this 1, 2, 3, 4. We'll give a 5 to the phenyl. 1, 2, 3, 4, 5 to the phenyl, so that looks good. We'll call this one 6, 7, 8, and we'll just number that one. Carbon 2, the enolated carbon 2 attacked carbon 6, so this is going to be carbon 6, carbon 7, 8, and then 9, which is part of the 5-membered ring. So the carbon numbering checks out. We must have done this first step correct. Now, that's not the final product. The final product that we're trying to show the mechanism of has a proton on this oxygen, and so that's where water is going to come in. We can now protonate that alkoxide using water in just an acid-base reaction, and that will give us this product, still showing the equilibrium. Now, notable in this step is that we're going to produce hydroxide again. Remember that the base aldol, the aldol with hydroxide, is base catalyzed, and we've regenerated that catalyst here. But this is the mechanism of formation of one of the crossed aldol products. The other 3 will form by a similar mechanism, just using either a different enolate, a different aldehyde, or both.